Have you ever wondered why critical raw materials are the lifeblood of the emerging hydrogen economy? It's no secret that the world is moving towards a greener and more sustainable future. This journey is paving the way for hydrogen to be a key player in the energy sector. But what's behind this energy revolution? The answer lies in the importance of critical raw materials, or CRMs for short. CRMs play a starring role in the hydrogen economy. They are the unsung heroes in the manufacture of key components like electrolyzers, which are the engines driving the hydrogen production process. An electrolyzer, if you're wondering, is a device that uses electricity to split water into hydrogen and oxygen, a process known as water electrolysis. Now, what's so special about these CRMs? It's their unique properties that make them indispensable. Take platinum group metals, which include platinum and iridium, for instance. These metals are not just precious, but they have specific characteristics that make them perfect for electrolyzers. They're highly resistant to corrosion and have excellent catalytic properties, making them ideal for promoting the chemical reactions in the water electrolysis process. However, these materials don't just grow on trees. They are rare and found in only a few places around the world. This makes them not just critical, but also a subject of geopolitical and economic concern. But let's not get ahead of ourselves. The point is, these critical raw materials are at the heart of the hydrogen economy. They're the key to unlocking the potential of hydrogen as a clean and sustainable source of energy. So without these critical raw materials, our dream of a hydrogen economy could be a distant reality. So what exactly are these critical raw materials we keep talking about? Well, to put it simply, critical raw materials, or CRMs, are materials that are of high economic importance to a region or industry, but face significant risks in terms of their supply. They are the linchpins of our modern world, often found in everyday products and systems, from your smartphone to the car you drive, and yes, even in the burgeoning hydrogen economy. Now let's get a bit more specific. One example of CRMs are the platinum group metals, or PGMs, which include elements like platinum and iridium. You might be thinking, platinum, isn't that the stuff they make expensive jewelry out of? And you'd be right. But these metals are far more than just adornments. They have unique properties that make them indispensable in various industrial applications. Platinum, for instance, is extremely resistant to corrosion and high temperatures. It's also a fantastic catalyst, speeding up chemical reactions without itself being consumed. This makes it perfect for use in fuel cells and electrolyzers, devices that are key to producing hydrogen, the fuel of the future. Iridium, on the other hand, is one of the densest elements on Earth, and it's incredibly resistant to heat and wear. This makes it ideal for use in spark plugs and other high-performance applications. In the context of the hydrogen economy, iridium is used in the production of electrolyzers, which are critical for the process of water electrolysis, a method of producing hydrogen and oxygen. But what makes these materials critical? It's a combination of their unique properties, their importance to the economy, and the risks associated with their supply. For instance, these materials are often difficult to substitute with alternatives and are sourced from regions where there are political or environmental risks, making their supply chains vulnerable. Understanding what critical raw materials are is just the first step. Next, we need to understand their distribution and production. Did you know that the production and distribution of critical raw materials are concentrated in a few countries? Let's dive right in. The geographical distribution of critical raw materials, or CRMs, is surprisingly narrow. Just a handful of countries have taken the lead in producing these essential components of our modern world. Countries like China, the United States, and Myanmar are the front-runners in this race. They are the dominant producers of these materials, making them the de facto kingpins of the hydrogen economy. China sits atop the throne, holding a significant portion of the world's production of rare earth metals. These metals are crucial for a myriad of industries, from technology to energy. They are the lifeblood of the hydrogen economy, and China's control over their production is significant. Meanwhile, the United States, rich in resources, is another major player. Home to vast reserves of minerals and metals, the U.S. is a key contributor to the global CRM supply. This geopolitical and economic advantage allows it to be a formidable force in the production and distribution of these materials. Then there's Myanmar, a lesser-known but equally important player. Despite its smaller size, Myanmar is a powerhouse in the production of certain CRMs, making it a vital cog in the global supply chain. However, this concentrated production and distribution have implications for the global hydrogen economy. It creates a risk of supply chain disruption, as any geopolitical or economic instability in these countries could potentially impact the availability of these essential materials. This vulnerability underscores the need for a diversified and resilient supply chain, capable of withstanding shocks and disruptions. A concentrated production makes the supply chain vulnerable, but we have strategies to mitigate this. Can we create a sustainable pathway for the hydrogen economy by efficiently managing our critical raw materials? Well, the answer is a resounding yes, and here's how. Firstly, we have preventive strategies. These involve identifying alternative materials which can perform the same function as our critical raw materials. For instance, instead of relying solely on platinum group metals and electrolyzers, we could explore more abundant alternatives like nickel or iron-based catalysts. This strategy could significantly reduce our dependency on these critical materials. Next, we have extension strategies. These are about maximizing the lifespan of our critical raw materials. By improving the durability of our products, we can extend the use of these materials and lower the demand for new ones. This approach is all about getting the most out of what we already have. Lastly, we have recycling strategies. This involves recovering critical raw materials from end-of-life products and reintroducing them into the production cycle. It's like giving these materials a second life. This not only reduces the need for new material extraction but also lessens the environmental impact associated with mining and processing. Together, these strategies can save up to 95% of critical raw materials. Now, that's a game changer. It means less dependency on a handful of producing countries, reduced environmental impact, and more resilience in our supply chains. But it's not just about the strategies themselves, it's also about how we implement them. We need to ensure that these strategies are integrated into our systems and processes, from design and manufacturing to end-of-life management. And we need to work together across industries and borders to make it happen. By navigating the complexities of critical raw materials, we can contribute to a greener and more resilient energy future. Together, we can shape a sustainable pathway for the hydrogen economy, one where our critical raw materials are not just critical, but also sustainable. So let's take a moment to reflect on what we've learned today. We've delved into the world of critical raw materials, the unsung heroes of the hydrogen economy. These materials, including platinum group metals like platinum and iridium, are the key components in the electrolyzers which produce hydrogen and oxygen through water electrolysis. Their unique properties make them indispensable, yet they also present a challenge due to their rarity and the complexity of their production and distribution. We've also discovered the importance of understanding the production and distribution of these materials. The leaders in this field are countries like China, the United States, and Myanmar. But the supply chain can't just rely on them. It's crucial to strategize and diversify to ensure a steady supply of these critical raw materials. Then we discuss strategies for sustainable management of these materials. With the right preventive measures, extension strategies, and recycling programs, we can save up to 95% of these critical raw materials. This is not just about economic efficiency, it's about creating a sustainable pathway for the hydrogen economy. Remember, every step we take towards understanding and managing critical raw materials brings us one step closer to realizing the hydrogen economy.